You're lying in a hospital bed. Machines are beeping in steady rhythm. From the outside, you look almost peaceful, pale, maybe, but still. A nurse checks a monitor, adjusts something, moves on. Nothing about this room looks like an emergency, but inside your body, a war has already started. Your organs aren't failing randomly. They're failing in a sequence of specific, documented, terrifying order that doctors have mapped down to the cellular level. They can watch it happen in real time. And in the worst cases, they cannot stop it. Here's what most people never think to ask: what does shutdown actually look like from the inside? What is the body actually doing in those final hours? And here's the detail that will change how you think about all of it: the organ that starts the entire collapse almost never gets the blame. It isn't the heart. To understand how the body shuts down, you first have to understand what it's actually doing when everything is working. Right now, without any conscious effort from you, your heart is beating roughly 100,000 times today. Not this week, today. Your kidneys are filtering approximately 200 liters of blood every single day, processing waste, balancing fluid, making thousands of micro adjustments per hour to keep your chemistry exactly where it needs to be. Your liver is simultaneously running over 500 distinct biochemical functions, producing proteins, neutralizing toxins, regulating hormones, managing energy, all at once, all without you thinking about it for a single second. This is called homeostasis, the body's relentless drive to maintain stability, and the scale of it is almost incomprehensible. Every organ is constantly talking to every other organ through electrical signals, hormones, and chemistry. Millions of parallel processes running in perfect coordination every moment of your life. It is, without exaggeration, the most complex system ever known to exist. Which is exactly why what happens next is so devastating. Because this machine, this impossibly intricate, self-regulating machine, has a failure point. And when that point is breached, the entire system doesn't hold. It cascades. The trigger. When one system cracks, doctors have a name for what happens when the body begins to fall. They call it Multiple Organ Dysfunction Syndrome, MODS, and it is, by every clinical measure, the leading cause of death in intensive care units worldwide. Not heart attacks, not strokes, MODS. The slow sequential failure of system after system after system after system. The mortality numbers are brutal. If 2 organ systems fail simultaneously, you're looking at death rates between 30 and 40%. 3 organs, and that number climbs past 70. 4 or more, and some studies place survival odds below 20%. Doctors aren't watching a single thing go wrong. They're watching a chain reaction they triggered but cannot always stop. So where does that chain reaction begin? This is where most people, and honestly, most non-specialists, get it wrong. The assumption is the heart, or the lungs. Something dramatic. Something central. But in the majority of documented MODS cases, the first crack appears somewhere far less obvious. It appears in your gut. Specifically, in the lining of your intestinal wall, a barrier only a single cell thick that separates the bacteria living in your digestive system from everything else inside you. Under normal conditions, that barrier holds perfectly, but under severe physiological stress, trauma, infection, blood loss, major surgery, it begins to break down. And when it does, bacteria that belong in your digestive tract begin leaking directly into your bloodstream. That's the trigger. Quiet, invisible, and the thing it sets off next is far worse. Escalation 1. The immune system turns on itself. The moment bacteria breach that intestinal wall and enter your bloodstream, your immune system does exactly what it's supposed to do. It detects the invasion, it sounds the alarm, it launches a full-scale response, and that response is what starts killing you. This is sepsis, and it is not rare. Sepsis kills approximately 270,000 Americans every year, making it one of the leading causes of in-hospital death in the United States. Most people have never heard of it. Most people who develop it don't recognize it until it's already won. Here is what it actually does to your body. Your immune system begins flooding your bloodstream with chemical signals called cytokines, molecules designed to coordinate an attack against the invading bacteria. But the flood becomes overwhelming. The signals don't stay targeted. They start damaging healthy tissue. Blood vessels throughout your body dilate uncontrollably, and your blood pressure begins to collapse. Your heart races to compensate, pumping harder and faster, trying to push oxygen to organs that are suddenly starving for it. This is called a cytokine storm, and the devastating irony is that your immune system, the system built to protect you, is now the primary source of damage. It isn't fighting the bacteria anymore. It's fighting you. Your lungs are struggling. Your kidneys are straining. Every organ in your chest and abdomen is watching its oxygen supply disappear in real time. But here's the thing. It gets worse. Escalation 2/peak danger. The cascade begins. ICU physicians have a term for what happens next. They call it the domino sequence. And once you understand it, you will never think about your body the same way again. The lungs fall first. As the cytokine storm tears through your vascular system, fluid begins leaking out of damaged blood vessels and flooding directly into your lung tissue. Your air sacs, the tiny chambers designed to pull oxygen from every breath, fill with fluid they were never built to hold. This is acute respiratory distress syndrome, ARDS, and it affects approximately 190,000 Americans every year. Breathing becomes labored, then desperate, then mechanically assisted. The oxygen your other organs are already screaming for is now even harder to deliver. Then the kidneys go. Starved of adequate blood flow and overwhelmed by the toxic byproducts flooding the system, the kidneys lose their ability to filter. Waste that should be leaving your body begins accumulating in your blood instead. The chemical balance your cells depend on, the precise ratios of sodium, potassium, and acid that allow organs to function, begins to collapse. Then the liver. Without sufficient oxygen, liver cells begin dying in clusters. The liver stops processing toxins. It stops producing the clotting proteins that keep your blood behaving the way blood should. Internal bleeding becomes a compounding threat on top of everything else. And then, finally, the heart. Not because the heart was weak, but because no heart, no matter how strong, can maintain circulation against a vascular system in complete collapse. Once 3 organ systems are failing simultaneously, clinical mortality rates exceed 70%. The body is still technically alive, but it is shutting down with the same terrible order and precision that once kept it running. Some people survive this, and what happens inside them is almost stranger than the collapse itself. The survival anomaly. Why some bodies come back here is where the story changes. Because some people survive the domino sequence, not most, but some, and the biological reason why is one of the most remarkable things happening in modern medicine. When cells are pushed to the absolute edge of oxygen deprivation, some of them don't die. Instead, they do something that researchers are still working to fully explain. They power down. Mitochondria, the structures inside your cells responsible for producing energy, enter a kind of hibernation state, dramatically reducing their energy consumption to preserve what little oxygen remains available. The cell essentially goes quiet, waiting, conserving just enough function to restart if conditions improve. Scientists call this mitochondrial hibernation, and it may be one of the primary reasons some bodies pull back from the edge, while others don't. But biology alone isn't enough. Intervention matters enormously. In 2004, an international coalition of critical care specialists launched the Surviving Sepsis campaign, a standardized, evidence-based treatment protocol designed to give clinicians a precise response framework the moment sepsis is identified. Early vasopressors to stabilize collapsing blood pressure, aggressive fluid resuscitation, rapid antibiotics. The campaign has measurably reduced sepsis mortality in hospitals that implement it fully. And then there is what researchers call organ crosstalk, the emerging understanding that organs actively signal each other during crisis, and that some can partially compensate for a failing neighbor, buying critical hours. Survival from 4-organ failure is rare, but it is documented. It happens. And when it does, medicine still cannot fully explain why. The ones who don't make it what the final moments look like clinically. For those who don't come back, the final phase has its own terrible order. Cardiovascular collapse comes when the heart, exhausted and starved, can no longer generate enough electrical activity to sustain a rhythm. Doctors watching the monitor see it happen in real time, the pattern growing irregular, then weak, then finally flat. This is a systole, not the dramatic shock of a heart attack. A quiet, gradual surrender. From that moment, a clock starts. Brain cells, completely dependent on oxygen-rich blood, begin dying within 4 to 6 minutes of circulation stopping. That window is well documented in resuscitation medicine, and it is unforgiving. Beyond it, the damage becomes irreversible regardless of what happens next. In the hours before this, there is often a sound. Clinicians and palliative care specialists call it the death rattle, an altered, low breathing pattern caused by the throat muscles relaxing as the brainstem loses its ability to coordinate even involuntary function. It is not painful. It is simply the body's final system, winding down. What is striking, in the end, is the order of it. The same precision that ran 100,000 heartbeats a day, that filtered 200 liters of blood, that held millions of processes in perfect balance, that same precision governs the silence. What your body is doing right now, while you watched this, your heart beat several hundred times. Your kidneys kept filtering. Your gut barrier held. Your immune system patrolled, identified, and neutralized threats you never felt. Every invisible process, running in perfect sequence, without a single conscious instruction from you. You are, right now, an extraordinarily unlikely thing to be. Alive is not a default state. It is the result of 1,000 systems refusing to fail simultaneously, every second of every day. Now you know what breaks first. Not the heart, not the lungs. A single-cell thick wall in your gut, and the catastrophic chain reaction that follows when it gives way. The domino sequence has a starting point, and it is nothing like what anyone expects. Tell me in the comments which part of this surprised you most. The gut? The immune system turning on itself? Most people guess the heart when I ask them. Most people are wrong. And if you want to see what it looks like when someone survives conditions that should have triggered full organ collapse, a real, documented case where the body came back from the edge of the domino sequence, that story is next.